Have you ever stopped to wonder what might be beyond the limits of what we can see and observe? What secrets and mysteries could be hidden in the vast expanse waiting to be uncovered? In this video, we will embark on a journey to the edge of the observable universe and explore the mysteries and wonders that lie beyond the cosmic horizon. From the infinite expanse of the multiverse to the breathtaking concept of the end of space and time, there are many theories about what might lie beyond the observable universe. Join us as we dive into the unknown and discover the probability that await us in the vastness of the cosmos. Before we begin our journey of exploration, it is important to have a solid understanding of the commonly asked questions about the observable universe. Let's take a moment to review these key concepts in order to gain a deeper understanding of what lies beyond our observable universe. First of all, what is the observable universe? The observable universe is the portion of the universe that we can see, given the finite speed of light and the time that has passed since the Big Bang. It is estimated to be around 93 billion light-years in diameter and contains billions of galaxies, each containing billions of stars and planets. Our own Milky Way galaxy is just one of these, and it contains over 100 billion stars and planets. The observable universe is also filled with a vast array of other objects and phenomena, including nebulae, black holes, and quasars. The observable universe is thought to be expanding, and this expansion is driven by mysterious substances known as dark energy and dark matter. While we do not yet fully understand the nature of these substances, they are thought to make up the majority of the mass in the universe and to play a key role in the evolution of the cosmos. Is there a center to the observable universe? The center of the observable universe is Earth, because the observable universe is defined as the region of space that is visible from our planet. For example, if you were standing on the Earth and looking out at the universe, the center of the observable universe from your perspective is your current location on the Earth. If you were to travel to a different location and look out at the universe again, the center of the observable universe from your new perspective would be your new location. Similarly, if you were to travel to a different planet or galaxy and look out at the universe, the center of the observable universe from your perspective would be your new location on that planet or galaxy. To be more accurate, each person is the center of their own observable universe. However, this does not mean that each person is at the center of the entire universe. The concept of the center of the observable universe becomes less meaningful as the scale of the universe becomes larger, because the universe is expanding and there is no fixed point that everything is moving away from. The light that we can see from our telescopes is at most 13.8 billion years old and has traveled from objects that are currently 46 billion light-years away. Anything beyond this distance is currently beyond our observable horizon. However, as time passes, we are able to see light from even more distant location because it has had more time to reach us. Every minute, we see light from slightly farther away, approximately 3 light seconds farther. Our view of the cosmos is constantly expanding as we observe light from objects that are progressively farther away. We can continue to watch and wait as the universe ages and more distant light has the opportunity to reach us. Is there a central point to the entire cosmos? It is not accurate to say that the universe has a center. This is because the universe does not have a boundary or edge, so there is no outside from which one could define a center. One way to understand this is to consider the concept of the cosmic microwave background radiation, which is a faint glow of radiation that permeates the universe and is thought to be left over from the Big Bang. The cosmic microwave background radiation is the same temperature in all directions, which suggests that the universe does not have a center. If the universe did have a center, then the temperature of the cosmic microwave background radiation would be highest at the center and would decrease as you moved away from it. However, this is not what we observe. Another way to understand this is to consider the expansion of the universe. The universe is expanding, and all points in the universe are moving away from all other points. This expansion is happening uniformly, without any particular point being identified as the center. An analogy that might help is to think about the surface of a balloon. As you blow up the balloon, the surface of the balloon expands, and all points on the surface of the balloon are moving away from all other points. There is no center to the balloon because all points are moving away from all other points. Similarly, there is no center of the universe because all points in the universe are moving away from all other points. Where does the expanse of the universe end, if it does at all? The concept of the edge of the universe is a difficult one because it depends on how you define the universe. One way to define the universe is as everything that exists, including all matter, energy, and space. In this definition, it is not meaningful to talk about the edge of the universe because the universe is everything and therefore has no boundary or edge. Another way to define the universe is as the observable universe, which is the portion of the universe that we can see or otherwise detect with telescopes and other scientific instruments. In this definition, the observable universe does have an edge, which is known as the cosmic horizon. The cosmic horizon is the distance that light can travel since the beginning of the universe, and it represents the limit of what we can observe. It's important to note that the cosmic horizon does not necessarily mark the end of the universe itself. It is possible that there are things beyond the cosmic horizon that we cannot see or detect. The cosmic horizon is the maximum distance from which light or other signals can reach the observer at a given point in time. It is the boundary between the observable and the unobservable universe. The cosmic horizon is not a physical barrier or boundary, but rather a concept that represents the limits of our current understanding of the universe. It is determined by the age of the universe and the speed of light. The age of the universe is approximately 13.8 billion years, and the speed of light is approximately 186,282 miles per second. This means that the cosmic horizon is the distance that light can travel in 13.8 billion years. But this is not the case. The size of the observable universe is much larger than 13.8 billion light years. This is because the universe has been expanding over time, and the distance between objects has increased as a result. The distance from Earth to the edge of the observable universe, measured in terms of the expansion of the universe, is approximately 14.26 gigaparsecs, or 46.5 billion light years in every direction. That means the observable universe has a diameter of 93 billion light years. The cosmic horizon has expanded over time as the universe has expanded. The horizon of the early universe was smaller than it is now because the universe was younger and smaller at that time. As the universe has grown older and expanded, the horizon has also increased in size, enabling us to see further and learn more about the universe. Now, let's answer the most crucial question. What lies beyond the observable universe or cosmic horizon? In order to determine what might lie beyond the cosmic horizon, we must consider various theories about the universe. However, we are unable to observe anything beyond the horizon, so it is currently not known for certain what lies beyond it. There are three main theories about what lies beyond the observable universe: Multiverse Theory, the Infinite Universe Theory, and the End of Space and Time. Multiverse Theory. U.S. physicist Hugh Everett proposed the multiverse theory in the late 1950s. The multiverse theory is a hypothetical concept that suggests that our universe is just one of many universes that may exist. The idea of the multiverse is based on the idea that the laws of physics and the constants of nature that we observe in our universe may not be the same in other universes. There are several different versions of the multiverse theory, and the specific details of each version can vary. However, One of the most widely discussed versions of the multiverse theory is the idea of the cosmic landscape, which suggests that our universe is just one bubble in a vast ocean of other universes. According to this idea, there may be an almost infinite number of other universes, each with its own set of physical laws and constants. An example of how the multiverse theory might work is the idea of cosmic inflation. Cosmic inflation is a theory that suggests that the universe underwent a brief period of extremely rapid expansion in the moments after the Big Bang. During cosmic inflation, the universe is thought to have expanded faster than the speed of light, which would have caused it to inflate like a balloon. According to some versions of the multiverse theory, the process of cosmic inflation may have created many bubbles of space-time, each of which could have become a separate universe. This would mean that our universe is just one of these bubbles, and that there may be an almost infinite number of other universes out there, each with its own set of physical laws and constants. It's important to note that the multiverse theory is still just a hypothesis at this point, and there is currently no direct evidence to support it. However, some scientists believe that the multiverse theory may be the best way to explain certain observations and mysteries about our universe, and it is an active area of research in cosmology and physics. The infinite universe theory. The idea of an infinite universe suggests that the universe has no boundaries and no edges, and that it goes on forever in all directions. This idea is different from the concept of the multiverse, which suggests that there may be many separate universes that exist alongside our own. There is currently no direct evidence to support the idea of an infinite universe, and it remains a topic of debate among scientists. However, some theories and observations in cosmology and physics are consistent with the idea of an infinite universe. For example, the cosmic microwave background radiation, which is a faint glow of radiation that permeates the universe and is thought to be left over from the Big Bang, is observed to be the same temperature in all directions. This suggests that the universe is isotropic, or the same in all directions, which is consistent with the idea of an infinite universe. Another example of an observation that is consistent with the idea of an infinite universe is the concept of cosmic inflation, which is a theory that suggests that the universe underwent a brief period of extremely rapid expansion in the moments after the Big Bang. Cosmic inflation could have caused the universe to expand faster than the speed of light, which would have made it infinite in size. The end of space and time. The idea that the universe may have a boundary or edge beyond which there is nothing at all is a difficult concept to understand, because it would require a complete rethinking of our understanding of the nature of space and time. One way to try to wrap your head around this concept is to imagine standing at the edge of the universe and looking out into the void beyond. Imagine that you are standing on a platform, with the universe stretching out behind you in all directions. As you look out into the void, you see nothing but darkness and emptiness. There is no matter, no energy, no space, and no time. Now imagine that you take a step off of the platform and into the void. As you do, you suddenly find yourself outside of the universe, in a place where the laws of physics do not apply. There is no gravity, no light, no heat, and no sound. You are completely alone in a place where there is nothing at all. Of course, this is just a thought experiment, and it is not currently possible to actually go to the edge of the universe or to experience the end of space and time. However, this example can help to illustrate the concept of what it might be like if the universe does have a boundary or edge beyond which there is nothing at all. This theory is difficult to wrap your head around, because it goes against our everyday experience of the world. We are used to thinking of space as an infinite expanse that goes on forever, and we are used to thinking of time as an eternal flow. However, if the end of space and time theory is true, then these concepts would not apply outside of the universe. If our universe is just one small part of a much larger multiverse, then what lies beyond the boundaries of that multiverse? I left this question for you to answer. In conclusion, the question of what lies beyond the observable universe is a deeply fascinating and mysterious one, and it is a topic that continues to captivate the imaginations of scientists and laypeople alike. While we may never be able to definitively answer this question, the very act of considering it forces us to think deeply about the nature of the universe and our place within it. As we continue to learn more about the cosmos, it is possible that we will uncover new clues and insights that will help us to better understand the mysteries of the universe and what lies beyond the cosmic horizon. Thank you for joining us on this journey of exploration and discovery, and we hope that you will continue to be inspired by the wonders of the cosmos. If you liked the video, hit the like button and subscribe to our channel.